So the picture, by the way, is Uncart Electra. Yesterday, you guys missed that one, so I show it. But the story I'm going to tell, it's nothing to do with the Electra. But, okay, here's the two things. I can't I escape this opportunity to tell my fun stories during Boris. So I'm going to add some fun stories at the beginning, and then I'm going to talk about actually exciting science. It's not that boring. Okay, so here we go. First thing is the CO2 advection. And this is a really fun. I wish I have an opportunity like this again. And as I got to Boris field experiment through Oregon State University, I was a postdoc there with Larry Mart. And I got there, we're trying to study, using radiation temperature, how to get the turbulence fluxes, and turbulence is, it's the things on our mind. So when we got there, we heard stories from tower people, like they have a missing CO2. I said, really? And this is from Ray. He's more, tapped into that community. He said, really? So we talked to Andy Black, man, and he said, Andy Black, and then he said, I asked him, I said, really? Only at night? Yeah. Nighttime stable boundary layer, we have this special phenomena, drainage flow. Have you thought about that? And I remember his eyes. You gave me this nightmare. You think we're measuring CO2 here, all the CO2 is down below us and driven? Yeah, that might be the possibility. So one day we're at the shore of Candle Lake for lunch. Ray, Larry Mart, and me, or three of us, I was thinking, I think we might be able to prove this concept. How can we do it? And then we said, well, for example, if there's a lake like this, the cold air should drain over the lake, and then it will be convective at nighttime, just like this picture shows, will be convective. And then CO2 will be transported upward. So we can see it, right? Yeah, maybe that's possible. And then Ray is so lucky. We're so lucky to have the world-class, instrument guy next to us. Ray said, "Oh, I have a light core. I can do it." Say, "Yeah, we need to find the boat." So we look around and we find that this guy said, "Yeah, the only boat I have is called the party boat." I said, "Wow." And we tell Larry, say, "Larry, do you have trouble to get reimbursed the party boat?" And I said, "Let's try it." And then say, "Okay, we're all set. We have the boat, and Ray has the light core. We can put on there and just cruise around." Then we turn around, talk to Ian, say, "Wow, it will be good opportunity for you guys to fly at night." And they said, "Well, we can't fly too low at night." "Oh, how about you take off at the night, and then by the time you get to the Candle Lake, and it will be really just a little bit of light you can see, so you fly low." So, and then they all jump on that. They say, "Really, you think that's going to happen?" Because the Candle Lake, we fly so many times, that's our lunchtime, because that's so smooth over Candle Lake. I said, no, it's nighttime. You will see bumpy ride, over a lake. So really, okay, it got into it. It's unbelievable. So we got the boat, and the night before the flight, we loaded the light core on the boat at 6 o'clock. I remember all the mosquitoes. Oh, unbelievable. So we got on there, and we cruised around. At that time, no one has a GPS scientist, but the boatman got the brand new GPS. So we got on there. I just have at least a spreadsheet. Said, okay, what's next? And I pull a pencil, and all the columns say, okay, lat long, and the boatman just shouted lat long, and I rolled it down. And say, then the Ray CO2 and the CO2, and then Larry has this the temperature sensor somehow. Okay, temperature. Then we just go around, and the pages after pages. That night was really productive, and it was beautiful. We saw the best polar light. Purple, green, yellow, unbelievable in the middle of the lake. So then we got in, and then we said next morning, Twin Otter is going to fly. So Larry and I would just stayed at the operation center next to the Kendall Lake. And so we just stayed there because the boatman is supposed to take us back to the lake, the 4 o'clock, So we just stayed there, and the 4 o'clock, and boatman showed up, and then we got up, and it was really fun. And then you just hear, hey, Twin Otter is coming, And then we have this walkie-talkie. It's unbelievable. Twin Otter, this is a party boat. Can you hear us? It was just unbelievable. There's a flying around, and then Peter Schrepp was on the flight. He said, Jielun, you were right. It was so bumpy over lake. Unbelievable. And then we just had so much fun. And then after they fly, we said, okay, this is one leg. We designed all these things. So after they finished it, they said, Jielun, sign off. And then they zoom in and fly really low, just above our boat, just take off. It was unbelievable. And then by the time we got back to the shore, and Ray, we're supposed to pick up Ray at the 8 o'clock. We saw Ray 200 meters distance. Hey, Ray, we're coming. And then, dun, 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 dun. The boat ran out of gas. So I have to just paddle, hey, Ray, I just all the way in. It was really fun. It's unbelievable. So that's what we did. So here, just to show you, not only we got this concept, just say, let's improve the concept. We did a measurement and had a flight within a week. It's just unbelievable. And here's the data, basically just to show lake was really warm at the night, radiation temperature, and you see after remove the mean flow, the air, does come in convergent. It's just like a chimney, like what we predicted. This is the CO2 measure from the Kendall Lake, from the boat. You can see it's just really high. It's unbelievable. So that's the fun part. And another part, I just mentioned how much time now.
You have about 2 minutes, but
okay. Okay, maybe I just kind of tell you the take-home message just quick. And so we measured the surface radiation temperature. It turned out to be, if you want to use this Balk formula, the Balk formula is designed for monitoring turbulent mixing. So when you use that, you need air temperature instead of skin temperature. That is issue. We're trying to figure out how much the difference. And so, even today, this is an issue. If we don't address this, it's hard to use the radiation temperature. You run into the so-called modelers all experience called the runaway cooling. You coupled with the skin temperature, it's not what it's supposed to be. Okay, and this is, I just briefly mentioned, the reason you cannot use the surface radiation temperature is the heat coming out from the surface. It's through molecular diffusion. And turbulence essentially just mix the cold, the warm air upward. It cannot lower the temperature of the surface that fast. So that is the problem. And because of this issue, I believe that's why we have a surface energy imbalance. It's a part of the issue. It's not the whole story. Because we're talking about the energy, the radiation get into the surface, and then the surface, the heat below the surface, it's all molecular diffusion processes, molecular thermal conduction. So the energy coupled at the surface should be all molecular diffusion process. While turbulence measurement is over there, there's a difference between turbulence mixing and the molecular diffusion. That's the content of the difference. And we know the surface energy imbalance is the maximum around the noon. That explains the whole story. And also in addition, these challenge you, hydrologists, ecologists. Basically, one thing is when you deal with the soil surface, When we deal with this mass balance, the mass actually of this system moves. It's moving mass, it's water. And that water comes in at a different temperature and come out at a warmer temperature, whatever that temperature is. And so there's a missing energy we didn't consider before. In addition, as I said, molecular diffusion, turbulence mixing, they're different. Molecular diffusion, you can use the thermodynamic equation, just the temperature increase equal to the heating you added into it. But when you deal with the turbulence mixing, you heat generate thermals. The thermal has kinetic energy. So you have to deal with this total energy balance. Heat come in, it's not just a temperature increase, it's kinetic energy, and the kinetic energy is associated with the dissipation. So even you introduce momentum conservation, there's an issue. I think that's the story. So I'm going to skip this, just mention, this is the observation, this is the Molniakov similarity theory. Same principle, because Molniakov similarity assume the turbulence mixing is associated with a vertical gradient of temperature or wind shear. The gradient is only this little. Turbulence eddy is not the same as the turbulent mixing, so that the delta, basically I just show up, there's a delta deal with your local gradient should scale with the turbulence eddy size. So that is the problem. And so we, over the several years, I've tried to cleared up this concept, and that's why you have a non-local turbulence counter gradient. So I'm just stop here just to say, we really need to address the issue, the difference between skin temperature and aerodynamic temperature. And with a new understanding of turbulence eddies, it's non-local, and you have to deal with the total energy conservation. That's